Namaste, Salaam. Hello friends, Namaste all of you, Namaste everyone, and myself, Shivaji Takalakar, of course, yours, friendly teacher. Dear friends, all of you are welcome, yours, congratulations, and I wish you have a very deep thinking day today, because the concept which we are going to continue, which we are going to study now, that is mole concept, is a very important and frequently used in a chemistry. Here, if you consider the atomic mass, molecular mass, or molecular formula mass, or formula mass, both can be combined together also, and molar mass. So all these terms are, of course, slightly different from each other, and it leads to your confusion. Now, we are going to put it a very simplified manner. Consider, if you consider the atomic mass or molecular mass, whatever it is, or molecular formula mass, put together, here it is expressed ALU, or also unified mass. Atomic mass means or unified mass, and always all the atomic masses and molecular masses, atomic or molecular masses are compared with 1/12 mass of carbon atom. Right? If you consider the example, if you consider hydrogen, that is 1 unified mass, or if you consider carbon, that is 12 unified mass, or if you consider the oxygen, it is 16 unified mass, or oxygen molecule, it is 32 unified mass, or atomic mass, also you can have AN, okay, or H2O, that is 18, okay. Now, if you consider how it differs from the molar mass, in this case, as hydrogen is atom, carbon, oxygen are atom, these are the molecules. So here, these are the formulas of the molecules. O2 is the formula, H2 is the formula. So formula mass, sometimes also known as formula mass, or molecular formula, both are same, formula or molecular formula, or molecular molecular mass, formula mass. Okay. So here, numerically, all these are somewhat different in the according to the hydrogen, carbon, oxygen. Right? So this is the unified mass. So it is nothing but the masses of a single particle. Okay. Single particle. Single carbon 12 atomic mass or unified mass of hydrogen is. So we compare to the hydrogen, these are the masses, and recently 1/12 of the mass of the carbon atom is considered. Okay. Now, in these cases, the formula mass can be defined as the sum of cubic here formula mass. Consider formula mass. writing here. It is the formula. Mass is the mass of all atoms in its molecular formula compared with 112 mass of carbon. Okay, formulas. This is also sometimes written as molecular mass or sometimes written as molecular formula mass. Of course, atoms or molecules all are very small particles, tiny particles, and their masses are therefore always very small, and it is for one single particle. This is given we compare to the hydrogen or 1/12 of the carbon. Okay, itself hydrogen and carbon is also defined. Now, how it is defined? Molar mass. Okay, consider. So, molar mass definition. What is it? It is the mass, that is of atom or molecule of course mass is a new atom of, that is this mass expressed in grams. Okay, so here one can say, if you consider hydrogen, that is 1 gram, or carbon 12 gram, or oxygen 16 gram, oxygen molecule 32 grams, or H2O molecule 18 grams. So these are nothing but the molar masses. So 1 gram is not now the mass of single entity. It is contains same number, Avogadro's number, MEA particles. That is 6.0 10 to 23 particles. It may be of atoms, ions, or molecules. Particles. That means this number of particles, their mass is this, and this is nothing but the molar mass. Denoted by M. Okay. So here N, right, in gram contains the mass of 6.0 right? So this number of particles, that is the mass. So in this case, if we consider all these elements, their masses. Now, one example is we are going to solve the problems based on this. Calculate the molar mass of carbon. Okay. Second, oxygen. H2. Excellent. Number of particles. Molar mass. So molar mass is expressed in grams. So these are these. But consider now how it is. So screen the shot, please. Calculate molar mass of carbon. As you know, carbon, right? That is its 112 AU atomic mass. Atomic mass of carbon is 12 AU. What it means? It is 12 times massive than hydrogen. In that, carbon isotope 12 itself used as a reference for to determine or to decide the atomic masses of the elements. So here, carbon itself is considered to compare to the hydrogen 12 AMU. 12 unified or also written as also the mass of carbon. So this is nothing but the mass of single carbon. This is the mass of single carbon atom. Okay. For your now you consider molar mass. We like to determine the molar mass. Molar mass, that is the mass of 1 mole. Okay. So here, you have defined AMU expressed in grams. Actually, it is the mass of Avogadro's number of particles. So this is the Avogadro's number of particles. One can also write here second definition. Also here second definition. First, second definition. Definition. Molar mass. It is the mass of 1 mole. 1 mole of substance. And what is 1 mole? 1 more definition. Which compare? It is the mass of 6.022 10 raised to 23 particles of substance. Okay. That is this 1 mole is nothing but the Avogadro's number of particles is 2. And therefore, molar mass is the mass of this number of particles, right? Molar mass is the mass of this number of particles. Okay. So here one can consider the same. Here, this is a single atom. There, mass of 1 mole, that is molar mass. Molar mass is equal to molar mass is equal to this is a single 12 AMU into 6.0 double 10 raised to 23 times. Right? This is in 12 into what is the unit? AMU. AMU are unified mass. Okay. Now, again, this is AMU. We have to convert it into the grams. But you know that 1 AMU or 1 U is equal to how much grams? Already we have derived and it is 1.66056 10 raised to minus 24 grams. Okay, this is by the definition of atomic mass, unified mass. Already we have defined the mass. Atomic mass unit or one unified mass, that is this one. That is this one. Okay. Then therefore molar mass, that is 6.022 10 to 23. Okay. So this one 12 into 6.0 double 2 10 to 23 AMU. How much? So of course this is equal to 1.66056 10 to minus 24 multiplied by this. Okay, multiplied by 12 into 6.0. Okay, so this is a 12 AMU, this one, and therefore it is of 10 divided by 1.665 into 10 raised to minus. This is in grams. Okay, in grams. So this is also AMU. And it is found to be 12 grams. 12 grams. This multiplied by this. Okay, 10 raised to minus 21 is equal to this 12 grams. So here, as per this, it is the mass EAMU of atom or molecule expressed in grams. That is nothing but the molar mass. So 12 AMU mass of the carbon, when expressed in 12 grams, that is the molar mass of the carbon. Consider one more example. Okay. Height, molar mass of it. Okay. And you know the formula mass or molecular mass. Molecular formula mass of H2O is equal to 18. Okay, 18. Unified 18. Then, of course, if by the definition, one can write here 18U. That is 18 gram is the molar mass. Molar mass. But how the concept? Deep thinking. Because today our day is deep thinking day. Okay. And this concept, more concept, is very interesting concept. Okay, so here 18. So this is a single atom, single molecule. It is mass of single H2O molecule. Single H2O molecule. H2O molecule here. Molecular mass. Molecular mass and molar mass, they are different. So here, in this way, okay. So here, as you know, 18U, that is a single mass, therefore, so here, consider now, similar as this molar mass, we like to find the molar mass of H2O is equal to the mass of, mass 1 AMU is equal to 1.66 0.6 10 to minus 24 grams. Therefore, this is 18 into 6.0 10 to 20 A. What? 1.66 0.6 10 to minus 24 grams multiplied by 12. Get me now. Here, 8. 1 A. 18 grams. So, as you know, the molar mass is the mass of Avogadro's number of particles. It may be atoms or it may be molecules. First thing. Okay. Or secondly, simplified form, that is, molar mass is the atomic mass or molecular masses in AMU expressed in grams. Okay, molar mass expressed in grams. Previous definition. So molar mass can be defined by 3 different units. Okay. Now consider next part. Our next point is average atomic mass. Actually, you can write the definition. It is the mean of atomic masses of isotopes of given elements. Okay. For example, if you consider one of the example, consider chlorine 35 and chlorine 37. Isotopes, same atomic number, different atomic masses. They are called as isotopes. Okay. So here it is found that they observe in the 3:1 ratio. So among 4 parts, 3 parts is the chlorine 35 and 1 part. So if you consider the percentage, this is 75% and this is nothing but the 25%. Okay, so this is the abundant. Abundance. That is. Yes. Okay. So in this ratio they are 3. So we have to take the means. Consider this one. Okay. 37 into 3 plus this is the 1 part, so 37. 30. This is 30. 30. Okay. Okay. Divided by mean or average atomic mass. Okay. So it is found to be 35. Okay. Because these are the unified masses of the isotopes of chlorine. So here the mean of percentage. Okay. So this isotope is 75%. So one can consider 35 into 75 plus. Okay. Mean or average atomic mass. Mean. Is okay, 75% plus, and this 37 is only 25%. So one can solve this. It will also come to be the 35.5 is the average atomic mass. Atomic mass is equal to 35. And for your information, this unified mass is taken in grams. It is the average atomic mass. 35.5 gram is average molar mass of molar mass. Molar means not necessarily it is a molar, but it is a concept. It may be an atom or it may be a molecule. Sometimes for our convenience, the atom mole or gram atom mole is also gram atom mole is also written as gram atom, or sometimes gram atom mole, or sometimes the mole simple. Okay, simply move. Only for atom. Gram atom. Gram atom means what? That is one mole atom. Molar. Okay. Consider now the one more example. Consider the example. There are three isotopes of neon: 20, neon 21, neon 20, and their abundance percentage is 90.92%, 0.26%, and 8.82%. Therefore, first contribution of isotopes in a given sample. So it is the atomic mass unit into its 20.92%. Here 21 isotope has its contribution like this in percent, and 22 the 8.80. Okay. If you consider to solve this and add this, okay, so here we can average is obtained, and average can be considered said to be one of the average. It is said to be 18.84. Then the 0.0546 and 1.9404. So here the addition of the contributions of all the isotopes is found to be the 90 point and it is said to be 179. Of course, it is very important for atomic mass in angular velocity if you can consider as per mass. And as per our definition, when this unitary mass when expressed in gram, that is 20 gram is atomic or molar Okay. So I am going to stop here.